Problem number 11 is an absolute value inequality. I want to come back and just review a few things on absolute values. First of all, whenever you see an absolute value, you need to think of distance. And when we measure distance, it always comes back positive. That's why we take the absolute value of any number, even if it's x. The absolute value of x has to be positive, but if we said it equals exactly 10, then there are two places on our number line that are exactly 10 units away, and we measure our distance in this example from 0. Distance has to be a subtraction problem. So when you subtract, the only number you can subtract from x is 0 without changing its value. So what numbers are exactly 10 units away from 0? Negative 10 and 10. So if we wanted to find the two locations that were exactly 10 units away, it would be at negative 10 and 10. Well, our problem isn't exactly equal to, it needs to be greater than or equal to. So if I want distances that are greater than or equal to 10, then I need to move away from those selected points that I found of negative 10 and 10. Now my distances are increasing. In essence, that's what we're doing in this problem here. It's a little bit more complicated because we're not measuring the distance from 0. If I had x minus 4, I'd be measuring the distances from 4. It says the distance between the number that you choose and 4 has to be greater than or equal to 10. So now, instead of 0 being in the center of our graph and going 10 units either way, 4 is the number that's in the center of our graph. We're going to march off 10 units to the right, so that's plus 10. We're going to march off 10 units to the left, that's a negative 10. And we're going to be at 14, and we're going to be at a negative 6. Each of these numbers are exactly 10 units away from 4. But we want to be exactly, we want to be greater than 2, so we're going to shade away. Once again, I want to keep reiterating that when you see a greater than or equal to, your distances need to be going outward. Now on this problem that we're working with, the absolute value of 3 times a number minus 4, we're finding the distance between a number that we can triple, subtract 4, that distance has to be greater than or equal to 10. The good thing about this problem, I'm going to clear off, start over so I don't have that off the side. But this problem falls into our GEMDAS category. We're solving an inequality, working backwards. I'd really like to get rid of subtraction, but I can't. It's inside a grouping symbol. I'd really like to get rid of multiplication, but I can't. It's inside of a grouping symbol. So the way that we break down our absolute values, once it's isolated, is we break it into a case 1 and then a case number 2. In case number 1, we know that our value inside here at 3x minus 4 could possibly equal a positive 10. But the second case is that 3x minus 4 could equal a negative 10, where if we took the absolute value, we wouldn't know any difference. It'd still come back as a positive 10. So now we solve each of these separately. So what I'll do is I'll add 4 to both sides. Then I'll divide both sides by 3. So if I divide both sides by 3, I get x equals 14 thirds. On the other side over here, we're going to add 4. This is 3x equals a negative 6. I'm going to divide both sides by 3. So x equals a negative 2. Now, I'm going a little bit differently than the textbook. I'm just putting equal signs in here right now. What I'm going to do is I'm going to find those anchor points by using the equalities. And then once I have those two anchor points, I'm going to put them in relationship on the number line. Negative 2, 14 thirds. I know that these would be the points that if I would triple them and subtract 4, they'd be exactly 10 units away from each other. But I want to make sure that I not only have them that are equal to, I want them to be greater than or equal to. So now, if I explain that other part correctly, you understand that, we want to move outside to make sure our distances are getting larger. So that's our solution set for number, I believe that was 11.